All right, we're doing a video. Let me check the stream, see how it's doing. Looks okay. I can get rid of this. Hold on. Trying to clear up my mess here. There. Okay, that's better. All right. Yes, I am back. Sorry about that. Topic today, pole shifts or pole flips and the relationship of all that to, well, all this. So we've had some crazy weather the last 2 months, really. Been really nutty here in the lower 48 United States. Oh, actually, it's been really nutty in Alaska, too. We don't hear much about that, but they've been having some wacko, freako weather up there. And so what do I want to talk about? Pole shifts, pole flipping. So this comes up a lot. I generally just discount it because I don't like to argue fringe theory of what they call folk science. I just learned that term recently. I don't like to argue with folk science. And one of the reasons is because people are entitled to their folk science. I don't really care. Believe whatever you want to believe. I mean, it's kind of fun to listen to people and all their theories. And, and I'm not poking fun at people. I'm just curious. What do people think? And they think all kinds of things. But that doesn't make it science. It's just, it's like folk medicine or folklore or all these kinds of things. It's just the stories we tell ourselves and each other about how the world works. And there's absolutely nothing wrong with that. That's very human. Keep humaning. Okay, keep being humans. I approve. Cougar approves. However, I am aware. And occasionally I will feel like I have to say something. So here I am saying something. Is there a pole flip happening? And is that what's giving us the crazy weather? And maybe even by extension, if they want to go a little further in their folk theory, global heating or climate change, whatever you want to call it. And the answer is, yeah, there is a pole flip. Well, no, let's not call it a pole flip. I'll talk about what that is. Words have meaning here, okay? There is a thing happening with the Earth's magnetic pole. And then there is a whole nother pole, which is the axis of rotation. And that's a whole nother topic. So which pole are you talking about? As for a pole flip, there are no pole flips. So that's the long and the short of it. If you haven't subscribed to the channel, there's more. If you haven't subscribed to the channel, though, and you'd like to leave now, please give us a subscription. I love explaining things. And like the video, and there's a link in the video to my novel. It was 100 Days. It's a post-apocalyptic novel. I really had fun writing it. I think most people are going to have fun reading it. And also there's a link to buy me a coffee. So if you want to support the work I do here, that's one way you can do it. So you've heard the short no, yes and no, yes and no. Yes, there is something happening with the pole. No, it's not a pole flip. End of discussion. Now, let's actually get into it, shall we? This is going to be a complicated video. I have lots and lots of visuals because this is actually a really complicated subject. And I like complicated subjects. And I kind of like it that people are into this. Okay, they're into this pole stuff, which is fantastic. I completely approve of this. I approve of people being involved in pole stuff. And you can be involved in a way that suits you and that's entertaining and it works great at the pub or the bar. And you can be involved in a way that's that aligns with science, which is a different way. And they're not exclusive. I mean, I wouldn't be aligned both ways, but certainly people can be. So you come here today for the sciencey stuff. And you go away and you tell whatever story you want to tell at the bar over beers. And actually, this shit that I'm about to share, this is really interesting. This is the real deal, folks. Sometimes the real deal is really interesting. And that's why we do this. That's why we sciencey people, that's why we do this. Because this shit's really interesting. So let's get into some interesting stuff. This is going to be complicated. I apologize if I have to rearrange my screens and do all this stuff. You're just going to have to put up with it. It's just me. I don't have a producer. Now I want to point out something here. The Earth actually has two poles. of relevance in this discussion. And I know as a fact that people frequently confuse them. They act like there's one, and that the one pole of the Earth does all the things. Well, that's not true. There's two. And they do different things. And they both do weird things. And so you could get all excited about the weirdness of the two poles. But they're separate. And they have nothing in common. And that's not exactly true. Well, maybe I'll straighten that out at some point. Theia. There's a word for you. Theia. Remind me to bring up Theia at some point. That's where these two come together. Ooh, conspiracies. Theia. It's all her fault. All right, there's two poles. And you can see them here in this picture. Let me get my drawing tool. I have a little drawing tool in my browser. So here's my drawing tool. Okay. Make a line. That's too heavy. Make another line. That's good. Okay, so there are two poles on the Earth. There have always been two poles. Oh, by the way, there's not always two poles. But currently there are. This is a contingent fact of history. This is actually really cool. The first pole that's of considerable importance is this one at the top of this picture. It's called the geographic North Pole. And for all these discussions, there's one that matches it in the south. In this case, there would be a geographic South Pole. The geographic North Pole is the North Pole. That's the North Pole. When we talk about the North Pole, that's the North Pole. That's the imaginary axle that passes through the globe around which the Earth spins. And the Earth does do that. And the Earth is a globe. And it does spin. And the axis around which it spins defines the geographic North Pole. It never moves, except that once it did. Once it moved. Billions of years ago. Billions of years ago, and I'm going to do this with my fingers, but this probably isn't going to work. I do have a picture, but I'll do this with my fingers first. At one time, the geographic pole of the Earth was completely perpendicular to the plane of the Earth's orbit. So the Earth goes around the sun in kind of a disk, and it doesn't deviate. The disk isn't completely square to the sun. It's a little bit of an angle. And all the planets are slight angles to the sun. So we have a little angle too. But it's mostly flat relative to the sun itself. And it goes around inside that disk. Sometimes it's closer, sometimes it's further, but it goes around the sun within the confines of that disk. This is called orbital mechanics. And the orbital mechanics were established at the same time the Earth was formed. So that was billions of years ago, right? And the orbital mechanics never change. The Earth wobbles a bit because the other planets pull on it and different things happen. But it's all physics. It's all mathematically calculated. And at one time in the beginning, a long, long time ago, the Earth was completely upright, perpendicular in the plane of the ecliptic of the orbit. It was completely perpendicular. And then the Earth was hit by a planetoid, small planet, called Theia. And Theia hit the Earth, and a couple of things happened. One, it hit the Earth so hard at an angle that it actually tilted the Earth a little bit on its axis. And it has remained tilted ever since. You don't tilt planets around. It happens once. Well, if it happens again, then it's a different event, all right? This kind of thing doesn't happen all the time. The tilt of the Earth is now established at about 22 or 23 degrees. It does wobble a little bit. You know how a top will wobble a little bit as it's going around? You see, you throw a top out on the ground and it's going around really fast, but at some point it starts to kind of wobble a little bit. That's called precession. And so the Earth does have a minor precession around of the axis, but mostly it's at an angle, and then it precesses slightly and slowly. And on human timescales, the precession of the axis of the Earth is imperceptible. It's been imperceptible in really evolved time. We've been around 300,000 years. It's unlikely the humans ever noticed that the precession was happening. We know it's happening because we can measure things very accurately with our instruments. The other thing that happened when Theia hit the Earth, in addition to just just knocking it off its axis, was it formed the moon. For a long time, people didn't know where the moon came from. It's weird. The moon is actually kind of weird. And people knew the moon was weird. And they were really curious to get up onto the moon with people walking around on the moon, as you do, and come back with moon samples because they wanted to see what was the moon made of. And one of the theories was the moon was made of Earth. And I mean Earth, capital E, not Earth as in dirt, soil. Earth, capital E. That the moon was made out of Earth, which presented another problem, like how did that happen? How did the Earth fall apart? Well, then they discovered something, and it kind of brought all the loose ends together. And it turns out Earth was struck by another planet early in the formation of the solar system. And the planet has been given the name Theia. And Theia both knocked the Earth off of its axis and created the moon from the debris. Theia, I have a theory on this. I'm not a geologist, but I can have theories. I mean, you're going to have theories, right? People talk about pole shifts. I have my own theories. Okay, I have my own folk wisdom here. I think Theia was responsible for creating the conditions that give us a magnetic field. So there you go. It's residual heat from the collision. Collisions cause heat. Just the deformation of rock and material causes heat. And I think Theia set up the conditions that exist to this day. It hasn't been that long. They give us a magnetic pole. So there is a tie-in between the geographic pole, which is tilted. There was a pole shift. Okay, this is where this gets really sketchy. Okay, there was a historic pole shift of the Earth, but it was like 5 billion years ago, or longer, 7 billion years ago, when the Earth was hit by another planet. And in the same way that one car hitting another can move pieces of the cars around, twist the wheels and bend the hood and knock the bumper off, okay, the Earth got damaged, okay, and it got knocked off of its axis, where it remains to this day. So that there was a pole shift. But that was a long time ago, and it hasn't happened since. It's just the way it is. It's like this is what happened after the collision. The Earth has been messed up, and it stays messed up because there's no fender shop. You can take the Earth to get that straightened out. The other pole that people like to talk about, going back to my drawing here, is what's called the magnetic pole. And I'll put another circle. I'm going to put a circle right here on the drawing to indicate where the magnetic pole has been since the time it was discovered. People I think it was maybe even the Chinese who first discovered that there's a magnetic north, as opposed to the geographic north, okay, which never changes. There's a magnetic north. And you could use a compass to find it, which is really convenient for people who are traveling on the oceans, right? Or even on land, for that matter. Knowing which way north is, well, you can always tell north at night because you can always see the pole star, which is the geographic north, okay? The pole star, Polaris, so-called, is at the geographic north, which is the only north we really care about. But for navigation purposes, like when you're at high seas, it's cloudy, whatnot, or even during the day when you can't see the stars, you can use a compass to find magnetic north. Well, about the time that humans were really exploring the Earth and using compasses to get around, and to know where they're supposed to be, the magnetic north and the geographical north were actually not that far apart. So the magnetic north was a decent stand-in for the geographic north, which is the real north. Now, science came along and started messing with things and confusing things. About 1831, we started getting data on where the magnetic pole really is. And it turns out it was in a different place than people thought. They had, by using compasses, they had been able to determine that the magnetic north was somewhere in this region, okay? Just by using compasses. Just by going up there and using compasses and say, okay, where does this thing point down? I know when I'm somewhere else on the Earth it points north, but somewhere it's going to point down, and that's the North Pole. And so they went up there and they found the North Pole as well as they could figure. Well, then science comes along with instruments and it says, hold on, the North Pole is actually way down here. Well, it turns out it's been moving, not flipping. That's a different topic. Pole flip is another topic. Only applies to the magnetic pole, by the way. But it's been moving. And then they were like, oh, that would be interesting if it's true. And so, after a series of measurements, they began to notice that it was moving actually towards the geographic North Pole, which was really curious. It's like it's moving a lot. In fact, it even accelerated at some point. It took it a long time to move from here to here, and then it moved from here to here really fast. That's not much time. And it moved a huge distance. So now, not now, 2020, when this image makes sense, the North Magnetic Pole has migrated to where it's fairly close to the geographic North Pole, which would be great for people using compasses if people still used compasses to navigate, but they don't. What do they use to navigate? GPS. GPS has nothing whatsoever to do with any of this. GPS is tied to the geographic North Pole, and that's it, period. GPS has nothing to do with magnetic North Pole. GPS is not a compass. GPS is not the global positioning system. GPS is not pointing at the North Pole, North Geographic Pole. GPS is pointing at GPS is not pointing at the North Magnetic Pole. It is pointing at the geographic North Pole. True north. GPS is true north. We don't need compasses to use GPS. Okay? Is that clear? Which is probably just as well because the North Magnetic Pole has been on the move. This is true. Everything I just said is true. It's also true that the geographic North Pole also had a tilt added to it 8 million years ago. 8 billion years ago. But the magnetic pole is also moving. Then they discovered something. By looking at ancient rock strata, that there have been times when the north and south magnetic poles reversed, so that the north magnetic pole was actually in the south. I mean, if you had your compass, you took your compass out of your pocket, 100 million years ago, and you set it on the table, it wouldn't point north. Your compass would point south. Now, you can still use it, of course, because if your compass points south, then you know where north is. It's the opposite direction. So it's not like it wouldn't work as a compass. It would still work as a compass. It's just it would be a south-pointing compass instead of a north-pointing compass. But you can still navigate. I'm being silly. Okay, obviously it wouldn't matter. But it is true that the magnetic polarity flipped. Now, this was a big discovery for scientists. Not only were they curious to suddenly realize that the North Magnetic Pole is not the same as the geographic pole, which they learned a long time ago, like back here in the 1600s, right? Well, actually, it was probably more like in the 1800s when they discovered that the magnetic pole is not the same thing as the geographic pole. I think that was probably a little bit of a surprise too. And then they discovered, not only is it not the same thing as the North Pole, it moves. Your compass will point in a different direction depending on what time of the century it is. So that was two discoveries. And then they discovered, shortly after that there are times when the magnetic poles reverse. So that's a pole flip, a pole reversal, whatever you want to call it. Let's look at some of that. Is that this picture? Yes, there's this picture. So this is a model of the Earth's magnetic field. It's two models, actually. The one on the left, called Between Reversals, is the magnetic field as we more or less experience it now. It has a north orientation and a south orientation. Well, but I want to point out, in even this left picture, the magnetic field lines themselves are really chaotic. They kind of know what's happening inside the Earth with regards to the magnetic field lines. They emerge in strange places and they twist around in strange ways. The Earth's magnetic field is twisted. There you go. During a reversal, which is the picture on the right, it goes through a series of twists on its way to being reversed. And this is a thousands-year-long project. Right now, the North Pole and the South Pole too, they're migrating, they're moving. But they still look like the image on the left. During a reversal, the magnetic field lines are expected to look like the image on the right. And they kind of know what it looks like during a reversal because there are geologic records in the stone itself of reversals. And if you go over the entire Earth, you can look at the same geologic strata and determine, so where was the North Pole during the reversal? And you can map. You can actually map what the pole lines were doing. This is all magnetic pole. The geographic pole never moved, okay? That one never moves. It moved once when Theia hit the Earth and knocked it off kilter. It has never moved since, except through tiny little wobbles of precession. This is the magnetic pole. And during a reversal, it gets really freaky. And they know this. The record for the freakiness is actually in the rock itself. So they can find where the rocks have a memory of where the magnetic pole was at the time that they were formed. And scientists, geologists, can use that record as inference to determine what did the magnetic field lines look like during the reversal. And we've had many of them. So there's many different times that they can go into the geologic record and say, well, what did it look like during this reversal? Okay, now, what did it look like during this other reversal? And they can map how reversal events proceed. So the image on the right is a typical reversal. And you'll see it doesn't look much like the image on the left, which is non-reversal. The image on the left could be migratory, like what we're seeing now. The poles, the magnetic poles, are moving around on the surface of the Earth. And that's a real thing. During a reversal, there are multiple magnetic north poles and multiple magnetic south poles. I don't know that they even know how these reversals happen or why. The internal mechanisms of the Earth have been studied extensively now, so we kind of know what's going on down there. But what causes a reversal? Why does it take so long? Why does it take thousands of years? Why does it happen at all? What happens to the Earth during a reversal? Some of these things are going to be somewhat unknown. Now, we do know one thing. Since we know when the reversals take place, we can look at life on Earth during a reversal, because not only is there in the stone, not only is there a record of what the magnetic field lines were doing, there's also a record of what the plants and animals were doing. We have fossils for those. And I don't think I've ever heard any theory that any extinction event was ever associated with a reversal. We've had many reversals. We've only had 5 mass extinctions. 5. Correct number of fingers. We've had 5 mass extinctions, and we've had scores of pole reversals. The Earth's magnetic field is actually fairly volatile. But it turns out it doesn't really matter. Not at the level of extinctions. It doesn't mean it doesn't matter at all. For example, there's some evidence that migratory animals, migratory birds, and of course there's migratory insects and fish, they might use magnetic field lines to navigate the same way that we do with a compass. Maybe they have an internal compass of some kind. I think there's even evidence that that's true. They have tiny little compasses. It's freaky. Look it up. It's amazing. Like I said, all this stuff is amazing. The truth of this is amazing. And if you want to get into some folklore about all this magnetic pole bullshit, get into it, man, because this stuff is amazing. Onward. So we might see interruptions to the way that animals migrate, and that would be bad for them, but it doesn't mean they go extinct. Migration is like a thing they do, but what happens if they don't do it? Do they go extinct? Maybe, maybe not. Even if you lose a few species of migratory animal during a pole reversal, that doesn't mean that the whole planet is suffering a mass extinction event. And we haven't seen mass extinction events associated with known pole reversals. So what does that mean for humanity if we have a pole reversal? Well, don't know. We're not in one right now. Might we be in the future? Yeah, possibly. But again, it's a 1,000-year-long event, 3,000-year-long event. Will we even know? If it happens that slowly, will humans even know that it happened at all? What evidence will there be that something is happening? I don't know. It might affect, anyway, moving on. This picture, pole reversals. Okay. I asked Google what pole reversal means, and there's a kind of a series of answers in here that I think are good enough that I'm just going to read them to you. You can do the same thing yourself. Pole reversals, all right? So I'm just going to read this to you because, of course, that's a waste of your time and mine, but I'm going to do it anyway because you're here and I'm doing science, and we're going to do science together right now because I think this is cool. This is coolio stuff. Doesn't mean you can't do your folk science. Please do. But this is also cool. Earth's magnetic poles reversing means the north and south magnetic poles swap places, a natural geologic event called a geomagnetic reversal, driven by flows in the liquid outer core, the geodynamo, that happens every few 100,000 years. So humans have been on Earth for 300,000 years. I don't think we've experienced the pole reversal in our evolved history. With the last reversal around 780,000 years ago. There you go. They can see it in the rocks. They can see the pole orientation in the rocks themselves. Fact. So they kind of know. Well, they don't kind of know. They know exactly when these things happen. Meaning it's overdue, but the process takes thousands of years, weakening the protective field, impacting technology and navigation, but not a sudden catastrophe. So, who knows? And like I said, there's nothing in the fossil record that suggests that this is a calamity. People like to get all hyperventilated about it. You want to hyperventilate about something? You can start hyperventilating about hothouse Earth. What happens during a reversal? Pole swap. Magnetic north becomes magnetic south and vice versa. There you go. Field weakens. The magnetic field strength drops significantly, about 90%, potentially for thousands of years before reestablishing in the opposite polarity. So you have a strong magnetic field oriented north to south, and then it weakens, and then there's a reversal event, and then it strengthens, and you have a new orientation, south to north or something like that. Complex field. During the transition, a field can become complex with multiple temporary poles appearing. That was this picture. Complex. The one on the right has multiple north and south pole orientations. Some of them near the surface, some of them deep down inside. Why does this happen? I don't know. Not a geologist. It's not my wheelhouse. It's interesting. You should look it up. The Earth's magnetic field is generated by the movement of molten iron in the planet's outer core, the geodynamo. Changes in the flow within this boiling pot of metal causes the field to fluctuate and eventually reverse. That's not really an explanation. It tells us how the magnetic field is formed. It doesn't really tell us how it reverses and why that's periodic rather than continuous. Those are interesting questions. I mean, thousands of years to reverse is actually really fast. For something that hangs around for 1 million years, for it to be able to reverse itself, go through a reversal and then be reoriented in a couple thousand years, that's kind of nutty. It's stable for 1 million years or longer, and then suddenly, like in the snap of a finger, it just flips the other way, and then it's stable for another 1 million years? What's that about? What is that about? That's weird. I don't care who you are. That's weird. Now, a geologist will tell you, oh, don't listen to him. There's nothing weird about it. Sit down and I have a bunch of equations for you. All right, fine. There's probably an explanation for it, but I'm telling you, it's weird. It's interesting that it can be stable for 1 million years, and then in basically the snap of a finger, geologically speaking, it can reverse and then be stable for another 1 million years. Weird. Effects and implications. And this is all the magnetic pole flip, okay? Which is a thing. It's happened many, many times in Earth's history. It has not happened, apparently, in human history, meaning the 300,000 years we've been around. Least of all, the 8,000 years we've been actually writing history books. No, not at all in 8,000 years, and hasn't even happened once in 300,000 years that we've been around. Compass readings would be unreliable, affecting traditional navigation. Traditional navigation. When you're using your phone and Google Maps to navigate across town, okay, you're not using traditional navigation. You're using GPS, which is tied to the geographical North Pole, true north. GPS navigation has no relationship of any kind to magnetic north. In fact, that's the reason why we have GPS, because it is reliable. In fact, it's reliable down to a couple of feet for military purposes, whereas the magnetic pole and its orientation isn't accurate to more than a couple of miles at any given instant, and then more like hundreds of miles over the course of a decade, because it moves, you see. That's a fact. A weakened field offers less protection from solar radiation, potentially disrupting satellites, power grids, and communication systems. Radiation, solar radiation from the sun. The sun puts out radiation that's actually really harmful. Normally, astronauts are aware of this, and we take care to protect our astronauts when they're out in deeper space. When humans start traveling to Mars, if they ever get around to doing that, not guaranteed, by the way, they will have to deal with hard radiation because they'll be outside the Earth's magnetic field. As it happens, the things like the International Space Station are within the Earth's magnetic field. So the ISS is completely protected, same as the surface of the Earth, by the Earth's magnetic field. There are a few exceptions to that, however, and I'll get to that in a minute. Biology, migratory animals, birds, turtles, whales, turtles. Oh, that's interesting. I didn't know about the turtles. That use the magnetic field for navigation could be affected. Yeah, probably. During a reversal. Okay, not when it's migrating, because I don't think they really care that much where the magnetic pole is, really. They just want it to be north. And right now it is. And it'll probably stay north. During a reversal, well, that might change them. They might have to make adaptations to that. But what the heck? They adapted to use the North Magnetic Pole in the first place. I'm pretty sure they can adapt again to use it if it's been moving or if it is flipped. I'm not too worried about navigation. And even if they can't navigate and they can't migrate, well, then they have to adapt to not migrating. What is this migration thing all about anyway? It sounds weird to me, so you don't have to do it. Stop doing it. I'm joking. Is it happening now? The last reversal was about 780,000 years ago, so we are, quote, due. I mean, that's not really true. But reversals don't happen on a predictable schedule. Exactly. We're not due. It's just that they don't happen quickly. They don't happen frequently. So it's been a long time, so maybe we're due. That's a lot of hand waving, okay? The field is currently changing and weakening in some areas like the South Atlantic anomaly. I'll get to that next. But scientists don't know if this indicates an imminent reversal or just normal fluctuations. Yeah, we're out in the weeds on this, folks. Whatever. It's already not that uniform. This is what we're dealing with, okay? It's not like anything you think. It's already kind of weird, and it's going to get weirder. Okay, fine. Well played. We'll deal with it. How long does it take? A full reversal is a slow process, taking hundreds to thousands of years. Yeah, so if there's a reversal, it's going to take so long that, first of all, humans and other animals probably won't even notice. And second, we're just going to have to deal with it for a long time. In fact, once it starts, there will be generations of humans, hundreds of generations of humans that will have to deal with this. This is not something that's going to happen in your lifetime or my lifetime. This is going to happen over evolutionary time. It's going to come in slowly, lots of warning. It's going to proceed a long time, and then it's going to finally slowly settle down, and it'll give scientists and engineers and technologists and governments plenty of time, if they care, to talk about it and deal with it, measure the effects, and change how we do things, and change where we live. And, you know, we have a whole new weather system. We have the daily weather, and then we have the daily magnetic weather, and we'll just adapt slowly, or we won't even notice, and we maybe don't even care. Who can say, right? We'll find out. The South Anomaly. So the Earth's magnetic field, as I've already alluded, is already not great. This is what we're talking about. This is the reality. And the South Atlantic anomaly is a disturbance in the magnetic field, not the surface of the Earth. This is not a supervolcano. This is not an ozone hole. This is not this is the South Atlantic anomaly. And it moves around too, and it has gotten bigger, and it looks like it's about to split. And in this picture, where's my drawing tool? You can kind of see it. There's sort of, I don't know, why is that thing so big? There's sort of two poles to this thing, and it may be splitting, but that's okay because, folks, this is what the magnetic field looks like. It's a little bit freakazoid, okay? So if you're getting some of this going on at the surface or near the surface, well, surprise, surprise. Well, I'm not surprised at all, nor should you be. So this is what's happening with the South Atlantic anomaly. So we know that the magnetic field has anomalies in it. We know that it's moving. We know the North Pole and the South Pole are both migrating across the surface of the Earth. We know there's something going on inside the Earth. It just doesn't seem to be very important. Now, this anomaly actually is a bit of a problem. Satellites have to, if a launched satellite is going to be flying through this anomaly regularly, then it needs to be shielded. So the electronics are not likely to be damaged by solar radiation. That's a long sentence, right? There's a lot of technology in that sentence. Solar radiation from the sun, the particles can damage sensitive electronics. That's CPUs, GPUs, memory, hard drives, whatever else goes into a computer. Networking. All these satellites have all this stuff in it. Lots of computational equipment inside of a satellite. Well, some of that can be damaged by hard radiation from the sun. Normally, the magnetic field that encompasses the planet protects the planet and satellites from hard radiation from the sun. But in this anomaly, the magnetic field is a bit weakened. So solar radiation particles can penetrate deeper into the magnetosphere, the protective envelope formed by the magnetic field. And so if a satellite happens to be flying, it's in orbit, right? If it happens to be in orbit through this anomaly, it can get additional impacts from stray cosmic rays. Not good. And it's a real problem. And NASA's aware of it, and the European Space Agency is aware of it, and the people on the ISS, the International Space Station, are also aware of it. And anytime they find themselves drifting through this anomaly, they have to take evasive action, basically. Satellites, I don't know what they do. Do they shut them down? Do they monitor them? I don't know what they do. But when they fly through this anomaly, it's tricky. And if you think you're going to be putting up a satellite that's going to be flying through this anomaly, often you may want to add additional shielding, which is something they don't like to do because additional shielding is metal, and metal is weight. It makes the satellite heavier and more difficult to launch, and also creates complexity in the engineering. So they don't like to do that, but if they're going to be flying through this anomaly a lot, then they have to do that. So this is here. It's always been here. Well, yes. We didn't always know it was there. We figured it out later through science and accident probably. And so we know it's there, and we know it's moving along with everything else. This is perfectly acceptable that it's doing this. It's not scary at all. I have an image here for the tilt of the Earth. I'm going to get to that in a second. That's the migration. I'm going to do this one. Okay. Now, what is the tie-in with global heating? People will tell you that the reason the planet is heating is because there's a pole shift. Because they've heard about a pole shift like last year or 2 years ago. And global heating, of course, is now big topics right now. So in the media, Paris Climate Accords, all this kind of stuff. So they're thinking, I just learned about the pole shift, and I've been hearing that the North Magnetic Pole is on the move recently, which it is. That's a fact. That's this picture, right? No, I have a better one. No, where is it? Where is my picture? I just had it up. Did I lose it? Tell me which tab it was on. I told you this was going to be difficult. Oh, it was here. The only one I didn't click on. Okay, this is what's happening with the North Magnetic Pole. It is moving, and it's been moving a lot. See, here's 2020, 2015, 2010, 2007, 2005. That's a lot of movement in 15 years. It is definitely moving. And 2005 to 2000, no, that's just 5 years. That's still a lot of motion. And here we had measurements going back to 1948, from 1994 to 1948. Now it's really accelerated recently. So there's going to be a lot of talk in the media about accelerating pole flip or something like that. At the same time that people are hearing about, global heating is taking off. And so it's real easy in folk science. It's really easy. I don't even have a problem with this. This is a human thing to do. This is actually a good thing to do as a human. It's pattern matching. Finding patterns in nature. We've been doing this for hundreds of thousands of years as humans. Finding patterns. This is a good thing. Exercise your brain. Please do this often. But it's also okay to exercise your brain in alignment with scientific principles. Okay? So let's do that. This has been going on, this pole migration, not a pole shift. We are nowhere into this. This is not what we're doing. Okay? We're doing this, a migration. It might lead to a pole flip where the north becomes the south and vice versa. It might do that, but that's not what this is. This is a migration of the two poles. There's another one in the south. I don't even have a picture of it here. There might be one further down on this page. Let's see. Here, this is the North Pole. They're not even showing the South Pole. Yeah, they're not even discussing the South Pole. I don't know why. I guess it's because we don't use the South Pole for navigation, right? We use the North Pole, magnetic pole, for navigation. So there you go. It's moving, but it's not doing this. Don't confuse the two. It's doing this. That's migration. That's a pole flip. That's different. Flip and migration are not the same word. This is the pole moving, not flipping. It could flip. We are, quote, overdue, whatever that actually means. It could flip, but again, it's thousands of years. It's a 1,000-year project for the poles to flip. These changes, migration, can, and obviously you can see it here on the picture, can happen in a human lifetime. So here, 1948, I was born in 1959, so where am I? Well, it's about the same spot. So in my lifetime, from here to here, look what it did. It moved from Victoria Island, thereabout, Ellesmere Island, to pretty close to the geographic North Pole. How far is that? I don't have a scale here. 1,000 miles? Several hundred miles, right? It moved several hundred miles in my lifetime. But that's not a pole flip. That's a migration. And they can do that quickly. Pole flips take thousands of years. Ta-da. Okay? Ta-da. Math. Science. We're doing science now. And because this has been happening at the same time that global heating has been in the news, people come along and they say, ha-ha, I now know something, because I'm a sophisticated hominid ape, and I can do pattern recognition. And the pattern I have noticed is that the media are talking about pole flips at the same time that they're also talking about climate change. So, I now know something, and maybe I should get the Nobel Prize. I don't know. I would accept it if it was given to me. Okay, yes, very clever. Very clever. You're doing science. You're doing evidence-based science, and that's a smart and clever thing to be doing. Full points. Full points for being data-driven. Full points from me. You get the Cougar seal of approval. You're doing science. You just don't have all the data. Let me show you the data. This is global heating. This is not pole flip. I've been talking about pole flips and pole migrations and magnetic fields and looking at this stupid thing and looking at this stupid thing. And now we're looking at this. And this is a different type of stupid thing. This is global heating. All these pictures are what is called the hockey stick. These pictures all represent the surge in Earth temperature since about 100 years ago. This is a good one. I'm going to focus on this one. Let's see if I can find this. Here, that is not, here it is. Okay, we're going to enlarge this and we're going to take a look at this. So this is temperature. This is global temperature, the change in global temperature. This is the delta, the change. This is not the actual temperature. It's the change in global temperature. And they've put a line, which I can also emphasize. There's a line right here of 0, meaning average, if you like. We'll call it the baseline. That's the baseline. It's not actually at the base. It's the baseline. Everything below this line is technically cooler than our baseline. The baseline is just for discussion. Everything above this line is technically hotter than the baseline. So once we picked our average and we just arbitrarily put it here, it's not too arbitrary actually. It's a place of stability that we have identified that goes back about 8,000 years. So that corresponds to human history, actual recorded history, 8,000 years of human history, of human civilization, if you like. This goes 8,000 years. This goes back to the earliest days of Mesopotamia and Egyptians and earliest settlers in Asia and and all the great civilizations of Africa. This 8,000 year period was stable enough for us to establish ourselves into static, non-changing communities, which we now recognize in history. Mesopotamia, Greece, Rome, the Egyptians, all the dynasties in China, and then all the great civilizational events that took place in Africa during that 8,000 year period. Before that, we were just coming out of a glacial maximum. So down here at the bottom, when the glacier was at its maximum, the ice was really cold. It was 8 degrees colder than what we're calling our average. And then things began to warm. And why did things begin to warm? Well, I could do a video on the Milankovitch cycles, but I'm not going to do that. Then things became stable. At this line here, at 0, things became stable for a long, long, long time. About 8,000 years. And then over here, I'm going to erase this. Then over here, things went crazy. Crazy. Look at this. You probably can't even see this because it's so obvious. It's so intense. Look at this. Look at what happened. And how long is this line here? How long is this? If I were to draw this down, I'd get to about, it's like no time at all. Years before 1950. Okay, so that line comes down to about 0, which is 1950. So this line right here, this is 1950. And so this entire excursion, this arrow that I just drew up here, this excursion, this took place since 1950. Maybe a little bit before. Maybe let's just say 1900. Let's just be generous. 1900. So in the last 100 years or so, this massive heating of the Earth, which isn't seen anywhere in the historic record, nowhere in our recorded history, and even in the geologic history, which is all this back here, there's nothing like this that happens. Even coming out of the Ice Age, this period of time coming out of the Ice Age, what is this? This is 16,000 years ago to 8. This is an 8,000 year excursion. This from here to here took 8,000 years. From here to here took 100 or less. This is global heating. Now you have to ask yourself, okay, could it be the pole flip? There is no pole flip, people. There is no pole flip. All right? This has to be understood. There is this, a migration happening. The poles are moving, which might be a problem for navigation if you're using a compass, which might be a problem for migrating birds and insects and turtles because they have an internal compass. But that's it. It's a migration. The actual magnetic north is not the same as the geographic north. It never was the same. And right now, the magnetic north pole is moving. Actually, it's moved quite a bit. But it's not a flip. This is not a flip. This is a migration. This is a flip, people. Are you going to tell me that we can't notice the difference between a pole flip and a pole migration? Are you going to tell me that we don't have enough satellites in space and enough people on the ground with, what is it? Compasses, okay? That we can't see this going on. That's a pole flip. This is what's happening. That is not a pole flip. Are we going into a pole flip, a magnetic pole flip? Well, maybe. We're not there yet. We're not there. This is different than this. And are you going to sit there and tell me that a Boy Scout with a compass, a pocket compass, couldn't tell the difference? A Boy Scout with a pocket compass could tell you the difference between a migration, where is the magnetic north, versus a pole flip, where you have multiple magnetic norths, and none of them are north. A Boy Scout, or with a compass, can do all the science necessary to differentiate this from this. A Boy Scout with a compass. We are not having a pole flip, people. And if we did, it wouldn't take place like this is, where this took like 200 years. It's going to take 2,000 years. This transition takes thousands of years. This can happen in your lifetime. That's already been established. Here's my lifetime right here. That's not a pole flip. And you can't call it that, because we know what a pole flip is. Words have meaning. That's a pole flip. This is chaos. And you can determine the difference between this and this other thing using a pocket compass. A pocket compass. Least of all, magnetic flux gates. No, there is no pole flip. All right. Will there be a pole flip? Maybe, possibly. Okay. But even if there was, would it have anything to do with this? The answer is no. This is global heating. Now, I have been doing videos for years on this channel about global heating. This channel is about global heating. I do this kind of stuff, this kind of pole flip stuff, for fun, all right? Just for lighthearted relief, just to have a beer with somebody and argue about the pole flip hypothesis, right? Let's argue about the pole flip. You bring your folk theory and I'll bring my science theory and we'll argue about the pole flip, and that's what we're doing right now. I'm arguing with you about the pole flip, and I'm saying there is no pole flip. I got the receipts, okay? This is a pole flip. We know what pole flips are. We've got pole flips in the geographic record. This is what's happening. That's called a migration. That's not a pole flip. I got the data. And this is happening in my lifetime. My lifetime. Because migrations like this can happen quickly. But a pole flip takes thousands of years. We know this because we can see it in the geological record. In the rocks. They record. The rocks record what happened. Is that unbelievable? Can people just not believe that? I guess people could just not believe that. And then I guess I have nothing to say. This is global heating. Oh yeah, we've had heating events. Oh sure. The last one was when we came out of an ice age. It was getting colder, and then it got warmer. And we love that. We love the interglacial. And we've had 8,000 years of steady temperatures. This is the 8,000 years of steady temperatures. We love that. We love it. All of written human history is written during this period of time right here. And then, what the fuck is this? What the actual fuck is that? Well, I have a name for it, and you can not like it if you don't want to. It's not called a pole flip. It's not even called geomagnetic migration. It's called global heating, because that's what it is. That's what it is. The temperature of the Earth is not determined by the poles. The temperature of the Earth is determined by something called the greenhouse effect. We've known this for 250 years. Science, okay? The temperature of the Earth is determined by the greenhouse effect. It was Fourier who said, wait, something's going on here. The Earth is, according to black body radiation, which Clark Maxwell came up with, according to black body radiation, the planet Earth should be colder than it is. Why is the planet Earth so warm? And he did some math, and he determined, look at this. The atmosphere is retaining heat. The atmosphere is retaining heat. Well, that's pretty damn convenient because we have an atmosphere, and it's providing a valuable service. It's retaining heat. It's like throwing blankets on a bed at night. It holds the heat in. So that's great, and people later called it the greenhouse effect. And if you're trying to grow plants, flowers, ornamentals, whatever, in a cold climate like, say, England, you may want a hothouse. It's a house that's made out of glass. And how's that work? Well, it keeps the air from coming in. The air is cold, right? So you don't want that blowing into your garden. But it also allows the light in. Allowing the light in is good for the plants. They use the light. We all know that. But also allowing the light in heats the contents of the house. But because the house is made of glass, the heat can't escape. It turns out that's the perfect formula for trapping heat. You let the light in, and the heat cannot get out. And a greenhouse, a hothouse, works exactly on that principle. It lets the light in, but it keeps the heat from going out, and it heats inside. And the planet Earth is like a greenhouse. It's called the greenhouse effect. We're using words here because words have meaning, and the meanings are explicit. We know exactly what these words mean. These are not random words that someone pulled out of their ass one day when they were drinking beer. These are words with meaning. And the greenhouse effect heats the Earth. And Fourier knew that. He did the math. Svante Arrhenius came along. He says, you know what? There are some numbers associated with this. And if you were to double the greenhouse gases in the atmosphere, you would get a certain amount of extra heating. Because it's the things in the atmosphere, carbon dioxide, methane, and nitrous oxides, plus some other stuff, including water vapor, which is important. That's what clouds are made out of. It's the stuff in the atmosphere that traps the heat. There's no glass. There's no firmament like people used to think. There's no glass up here in the top of the atmosphere. But there are things in the atmosphere itself, invisible things, atmospheric components that trap heat, and are very good at it, by the way. And that's the greenhouse effect. Well, now, what has happened? What? I just wonder. I wonder if we can make any determination of what happened during this period of time, right here, right? I need a bigger pencil. What happened during this period of time from 1950 on, such that we got this crazy amount of heating? Well, if the heat of the Earth is established using the greenhouse effect, which it is because science, then if we were to alter the greenhouse effect in any particular way, then maybe the Earth would get hotter or it would get cooler. And it turns out we can manipulate the greenhouse effect of the Earth. People don't believe that. They don't want to believe that. They don't think that's possible. God created the Earth in a certain way. We can't change that. The Earth is too big. We're too small. Well, guess what? We did. And the way we did it was unexpected, but really, really easy. During this period of time right here, we dug up fossil fuels, which are made of carbon, and we set them on fire. We burned coal. Lots of reasons we burned coal. Originally, we burned it to heat water to make steam, and that was, the steam engines. And then later, we use it to boil water to spin turbines to generate electricity using generators. So we still burn coal. We found clever ways to burn crude oil and to use crude oil for other things besides setting it on fire, but we definitely burn it. And we also use natural gas, methane found in the ground, found often with oil fields. So when you find one, you generally find the other. And we have found clever ways to manage natural gas. It's not a liquid, at room temperature, so you have to put it in pipes and some other things, and the pipes are expensive, and it's infrastructure, so it took us a little while to get into dealing with natural gas. But we figured it out. Of course, we're clever apes. We figured out how to deal with natural gas, and now we have pipelines going everywhere. Oh, we even liquefied natural gas now. It's called LNG, liquefied natural gas. We put it on cargo ships and move it around the planet. It's really expensive, prohibitively expensive, but for some nations that don't have any other source of natural gas but still want it, generally for industrial purposes, not for home use, but for industrial reasons, then you can have LNG. And it's easy to store, easy to transport. It's just expensive to make. But what the heck? If you're using it for industrial purposes, you don't care. So during since the 50s, we've gone completely bonkers burning fossil fuels. And burning fossil fuels releases CO2 into the atmosphere, along with nitrous oxides, and acquiring fossil fuels often releases methane. So coal mine explosions are caused by methane explosions. There is methane, natural gas, associated with coal mines, and it's usually just vented into the atmosphere as is. Oil wells always have methane associated with them. That's why you see them with the little fires, the little flaring events. Have you ever seen the flares? Ever seen flaring? Maybe I should do this. I'll do a quick search. Gas flaring. This thing, okay? You'll go to a oil field where they got the jack pumps going up and down pumping the oil, and you'll see, here's a really nice picture. Yeah, nice. I mean, it's not nice, of course, it's horrific, but here's a nice picture of a flaring event. You can go to gas fields and they're flaring the natural gas. More recently, all these pictures are kind of horrific. More recently, they've been trying to find ways to save it, because you can sell it. It's worth money, but it's so expensive to collect this stuff that they just rather burn it. They set it on fire. They flare it. They burn it. It's terrible. And of course, it contributes to global heating when they're flaring this gas and setting it on fire. But sometimes they don't even flare it. Sometimes you just release it into the atmosphere. Like when they're coal mining, they don't flare that gas. That just goes into the atmosphere. Same with a lot of these oil fields. They don't bother flaring it. They just release it into the atmosphere, which is really dangerous because it's explosive. Yeah, you can have big problems. Here they are at a offshore oil well, flaring the gas away from the platform because it's fucking dangerous. You have to be careful with this stuff. And so that's what they're doing. This might be AI. Flare gas to power. Yeah, so here, this is interesting. We could even follow this. Flare gas to power. So rather than just flaring the gas and saying bye-bye, goodbye, they can actually use it. If you put a power plant associated with this facility, whatever this is, this could be a refinery. Looks like a refinery. If you put a power plant here and you collect that gas and you burn it to heat water, to make steam, to turn a turbine, hey, you just created electricity. So they're getting more sensitive about this natural gas. But sometimes they just burn it, or sometimes they just release it into the atmosphere as is. And methane is a powerful greenhouse gas, really powerful. So even if you're flaring it, you get CO2. So there's no escaping from the fact that these facilities, I'll pick this one, these facilities are contributing to the greenhouse effect because they're releasing either methane and or CO2 into the atmosphere, where it enhances the greenhouse effect, thereby heating the earth, thereby giving us this. You see? Now, you can say, this is because of a pole flip. There is no pole flip. There is a migration. Okay, fine. That happened in my lifetime. But that's not a pole flip. This is a pole flip. We're not having this. Do you think we wouldn't be able to notice that we're having a pole flip? Yeah, we'd have a pole flip. Plus, it would take thousands of years. It wouldn't take 50. So what we're looking at here. It wouldn't take 50 years. And then you'd still have to explain to me. Okay, science boy. You think that the global heating is caused by a pole flip, which we're not even having. Okay, let's just admit that right up front. A Boy Scout with a pocket compass could tell you if you're having a pole flip or not. So we're not having a pole flip. We could. We're not. But what does a pole flip have to do with any of this? We know what a pole flip is. A pole flip interferes with navigation. Not even human navigation anymore because we use GPS for that. But maybe insect navigation, turtles, birds, whales, okay? They might swing in circles or something. I don't know what they do. If they're trying to use the magnetic pole during a pole flip, they're going to be swimming in circles, maybe flying in circles, flying into buildings. I don't know. It's going to be terrible. But it's not going to be this. It's going to be turtles swimming in circles because they can't navigate. It's not going to be this. This has something to do with the greenhouse effect. And nowhere when I was talking about the geographic North Pole, I mentioned Theia and the Theia impact. Then nowhere when I talk about the magnetic pole, including the migration of the pole and the flux lines, and I mentioned what a pole reversal looks like. We've had many of them, lots of them, and they're not associated with either extinction events or major climactic events. We've had many of them. And if they were a problem in these ways, we would know. We would know. There'd be evidence for it. We're trying to do evidence here, people. We're trying to do science. Is that okay? That's what we're doing here. I'm a science guy. This is a science channel. I'm doing some science here. You can think whatever you like. I don't care. I think it's marvelous. It's entertaining. Think whatever you like. I love your stories. But I'm doing science here. So let's just do some science, shall we? And this is the greenhouse effect. We have fucked it up by burning fossil fuels. So there you go. And yeah, and I understand why people don't want to deal with that. But one thing, climate science is science. It's not folklore. Climate science is complicated shit. I've got 3 years of videos on this channel talking about climate science. And some of the earlier ones don't even apply anymore. There have been changes in just 3 years that are absolutely throwing our prior understanding of the Earth system under the bus. A lot of that has been thrown under the bus. Oh, should I show you some shit that's been thrown under the bus? Look at this. I was looking at this morning. That's why I have it queued up. I've been doing videos about this for like a month now and progressively losing my mind about this. What is this? This is the polar vortex, folks. You want to get all exercised about something? You want to get your undies in a bunch? You want to sweat and have heart palpitations and grab your buddy by the collar and shake him and try and shake some sense into him? Yeah, this is what you're talking about. This is the real deal. This is the polar vortex, boys and girls. That's the polar vortex. That is a fucking nightmare. Well, it just looks like a couple of plate full of bagels to me. Yeah, okay. That's what it's supposed to look like. That's the South Pole. That's the South Polar Vortex. That's what it's supposed to look like. And it looks like this. Time to worry, people. And the jet stream, which is driven by the polar vortex, which is high up in the atmosphere. The jet stream is lower in the atmosphere. It's the one we interact with, called the jet stream, because the jets discovered it. The high altitude jetliners, right? The age of jets, like 1950s, right? This is what the jet stream looks like. Now this isn't bad. This is finally back to a circle. If I go back 2 weeks, it was looking like this. This is some dangerous shit. This has actually been impacting the U.S. in a big way. And I go back another 2 weeks, it looks like this. What the fuck is this? What is this? What is going on here, people? You know, if you're me and you're in my shoes and you're trying to do sciencey shit and you see this, you're going to like, oh my God. That's going to leave a mark. And it did. And if we go back to a week ago, the 22nd, Thursday. Actually, let's do Friday. This is how things looked a week ago. Well, last Friday. Last Friday, for those of you who are just coming out from under a rock, last Friday we had cold weather, freezing rain inches of ice, massive disruptions in infrastructure, including frozen water supplies, damaged electrical supplies. There was 1 million customers without power in the U.S. South and Southeast. There's still, right now, a week later, 300,000 customers without power, and the temperatures never get above freezing because of this. I mean, I could do a separate video on this, but I'm going to do this right now because of this bullshit. This is the jet stream. It's looping down here, and it's bringing cold air down from the Arctic. This is the Earth dynamic system. This isn't even weather anymore. And if you've got an honest meteorologist, they'll tell you something like, our forecast models don't know what to do with this. They'll tell you that. They're not going to tell you that because they're a bunch of pussies. Okay, they're going to tell you, well, it's going to be hard to predict this. We know that there's record high temperatures up in Alaska. They're not going to tell you that either, by the way, because they're a bunch of pussies. There's record high temperatures up in Alaska right now. A week ago, Alaska was actually hotter than Florida. They're not going to tell you that either because they're a bunch of pussies. And this is bringing record cold Arctic air down, and this is bringing record hot equatorial air up, and this is the jet stream, and this is absolutely, completely freaking us out. And now you're going to have a huge a U.S. event down here in the lower states, and you're going to freeze your asses off, and you're going to die, and 50 people did die right here in the United States, right? Most advanced technological country on the planet, couldn't keep these people from freezing to death. So there you go. Oh, and by the way, if you think that's not enough, let's go to now. I have to change my tool out. Now I can go to now. It's still there. It's still doing its stupid shit. And now it's moved a little bit to the east. And now, starting a week after last Friday, this Friday, they're going to have another calamitous apocalyptic event. They're going to have, and I don't even know how this is happening, they're going to have a massive, right about here, they're going to have a massive cold core hurricane. A cold core hurricane. Not a hurricane that came across the South Atlantic and hit the Gulf Stream and went up here and rained in the Gulf states. That would be a normal hurricane. That's not what they're getting. They're getting this freakazoid. They're getting this Frankenstein monster, which is a cold core hurricane. Came out of nowhere, literally out of nowhere. Then it's going to go through bombogenesis, which is a 24 millibar intensification in 24 hours. And they're going to have 100-mile-an-hour winds off the coast, off the East Coast, 100-mile-an-hour winds. And they're probably going to have 70-mile-an-hour winds on the coast. And then, because this is a cold core cyclone, not a hurricane, it's going to snow. It's going to snow on the outer banks of the Carolinas. It's going to snow inland. And they're going to have, get this, they're going to have a whiteout blizzard. Because they're going to have 70-mile-an-hour winds, feet of snow, and it's going to be whiteout, a blizzard in the Carolinas, and so people are beginning to notice. People are noticing, and then they're coming up with pole flip. Oh, it's due to the pole flip. No, it's not due to the pole flip. People, can I science you? Can I just science you a little bit? Let's just do some science here, shall we? This is what's causing your problem, the polar vortex. This is how it looks. There's 3 of them. Can you see them? I can see them. You should be able to see 3 vortices here. 3 of them. There should be 1. It should be centered over the North Pole, and it should be well formed. Now there's 3. What the hell? And that caused this. That's your jet stream. And the jet stream, this is weird. I wasn't ready for this. 2 weeks ago, I was looking at something that was an absolute monster. And this is just looking strange. What's strange about this is the jet stream. It now extends almost to the equator. This is supposed to be the northern jet stream. Parts of it are extending as far south as the equator. What is going on? The jet stream is extending as far south as India. What is the meaning of this? What does it even mean? What is happening? That's data, people. That's data. That's why you're having these cold events. It's not weather. Well, it's winter. We always have cold in winter. This ain't winter. This is not weather. This isn't even seasonal. This is the polar vortex has been completely blown to pieces. There's 3 pieces now. Like your car was torn into 3 parts. There's 3 pieces to this thing, and it's doing terrible things to the jet stream, including allowing all this cold air into the lower 48. When does this reverse? When does this change? Well, there's no hope of it changing until this changes. And when is this going to change? Well, that's a good question, because this is driven by global heating. And what's the global heating look like? It looks like that, people. That's what the global heating is doing. It's a moonshot. It's going straight up like a rocket. And if that gave us this, then when does this go away? Never. This never goes away. And if this never goes away, then when does this ever go away? Never. And what does that mean? That's another discussion, isn't it? We could science our way through that one too. What if this never goes away? What does that mean? What happens to us? If this never goes away, what does this mean for human civilization? That's a question. I can't answer it. I could make some guesses. I could make some educated, science-y guesses. I probably shouldn't, and I probably should be done. So I am going to stop this. No, there is no pole reversal. The pole reversals look like this. You can detect this with a pocket compass. We're not doing that, okay? This is what we're doing. We're doing a simple migration. We still have a North Pole. It's on the move. That's fine. The turtles and the swans may not like it, but it's fine. It can be on the move. We do know that we have anomalies in the magnetic pattern. That's okay too. We know about them. They're moving kind of like the way the North Pole is moving, North Magnetic Pole is moving, and that's fine. We can plot them. We have a map right here, and we have to take extra care when we're trying to fly satellites and the ISS through this anomaly, and because there's going to be radiation events. So yeah, we can cope with that. That has nothing to do with this. That has nothing to do with this. You're gonna have to really put your thinking cap on to explain to me how how this baloney, which we can measure and have been measuring, how that has anything to do with this. Because we know where this comes from. This comes from the greenhouse effect being intensified by our combustion of fossil fuels. There you go. We've known about this for 200 years. And you can say it's not true, but you'd be wrong. Because science. And you can say science is a hoax and it's got a conspiracy and scientists are a part of the global order and they're all fear mongers and they're trying to take away our freedoms, and you can have all that thought and that's fine. It makes me laugh. I'm a scientist. I don't give a shit if you have guns or not. Why would I care if you have guns and freedoms? I mean, you have to look out for your own freedoms. I have nothing. I have no thoughts about your freedoms. You know? You're having more problems right now with Donald Trump and your freedoms than you are with scientists. This is the greenhouse effect. This is just science. This is some bad news here. This is bad mojo. This business right here. This thing? Yeah, that is not this thing, okay? This thing is a different thing. And this is called global heating. Good luck. Good luck with that. Good luck with that, Sparky. Yeah, you're going to need a lot of luck with that. You're going to need a lot of luck. I wrote a book on what you're going to need. I wrote a book. It was 100 Days. Link in the description. This is going to be bad. This is going to continue. This line is going to go just like this. That's what that line's going to do. That's how you draw that line, folks. That's how you draw that line. And what was it about this period of time here that prepared you for that line? Absolutely nothing. And if you want to call it pole flip and you're going to go over here and show me all this, I'm going to come right back here and show you this. What are you going to do about that? Because, yeah, maybe this will happen, and maybe your pocket compass won't work anymore, or the way it used to, or the way it should to be useful. Maybe your pocket compass, maybe your turtles will start swimming in circles. I have no idea, but this, yeah, this line right here, oh, you can't just draw that line. The fuck I can't. Oh, yeah. That shit's going to leave a mark. That's called hothouse Earth. That is going to leave a mark. So go on about your pole flip, sunspots, chemtrails, flat Earth, Jewish space lasers, alien invasions from Mars. You go on all about all that. It's fun. We'll share a beer and I'll laugh. I'll just laugh. And while I'm laughing and having fun, I'll be thinking about this. In the back of my mind, I'll be thinking about that. I'll be thinking, should I tell them? What good am I doing if I tell them? Right? You know, they're laughing and having a beer, and they got their folk theory, and it gives them some solace, and they can come pull this up and say, look, there's actual data that shows a pole flip. Well, this isn't a pole flip, this is a pole migration. Yeah, you're going to need this data to talk about a pole flip buckwheat, and you ain't got that because this is all you got. This is what you got. You got none of this, okay? And when this is all you got, you can talk about a pole migration, and then you're going to have to explain this, except you won't. And I just spent, an hour and a half setting up why you can't explain this. And I don't even need you to. That's my job. That's my job. I'm here doing my job. Does anyone care? Does this go anywhere? Does what I just did change anything? I do it as a public service. I do it because I value the truth. I do it because I'm a scientist, and for 200 years we've been pushing back the frontiers of what can be known and what can be studied. And now we know a lot. This chart is part of what we know. This map is part of what we know, right? We know things, and we know this, and we know that, and we know this other thing, and we know this stuff over here. We know some things. So I'm here to talk about what we know. And people can think what they like. And hothouse Earth is going to kill them. Hothouse Earth is going to kill them. A pole flip probably wouldn't. There's no evidence that pole flips cause massive extinction events. We've had scores of them. And we haven't had scores of mass extinction events. We've had five. And those are associated with things unrelated to the magnetic fields. But this event here, study the PETM. That was the last mass extinction event, the PETM, the Paleocene-Eocene thermal maximum. That's where this is going. You can have all the pole flips you want. All the pole flips you can come up with don't give you the PETM. This will. Oh yeah, this is it. We're on glide path for another thermal maximum, also called hothouse Earth. So that's what I have to say about that. Sorry. It was fun, but it wasn't fun, was it? Because it's not. The reality is not fun. And you can joke about your aliens from space and pole flips and magnetic anomalies, and you can point to all that and have a beer and get drunk and think you've made sense of the world, and maybe you've had a good time, and maybe it did make some sense, and it's your folk theory, and maybe it gives you comfort, but this is what's happening. This is what's really happening. This is happening. This is the instrumental record. This is what's happening. So enjoy your pole flip. If and when it happens, thousands of years from now, if and when it happens, enjoy your pole flip. and probably we won't even exist anymore. Not like we do now. We may not even have pocket compasses by that time. Remember, like the video and subscribe if you want more of this kind of stuff. I mean, why would you? But that's how we do this, right? That's how we do the algorithm. We ask people to subscribe and to like the videos. And what's to like? I don't know. Appreciation. Just appreciate that I do this. I appreciate when I'm appreciated. And sometimes it happens. Don't die.